Good morning students. Today we are going to discuss few more topic from chapter 4, and the chapter 4 is your motion in a plane. Now already we have discussed that as the chapter is defined motion of an object in a plane. That's why we have to use vector, because in a plane there are infinite direction. So if you have to specify any particular direction, then you have to use vector, because vector includes both magnitude and direction. So let me start with the topic unit vector. Now, as the name symbolize a vector whose magnitude is 1. So let me read out. It is a vector of unit magnitude and direction same as that of the given vector. Now you see, for every vector there is a unit vector, because unit vector specifically define direction, and every vector has its direction. So for any vector you will get a unit vector which specify the direction of the vector. So if a vector is the given vector, then its unit vector is denoted as a cap. Cap is basically used to define unit vector, this symbol cap. Now if there is a vector a vector, so its unit vector will be a cap, and is defined as a cap equal to a vector divided by magnitude of a vector. So you see, if you try to explain physically the expression, the numerator is your vector a vector, so it has both magnitude and direction, and the denominator is your modulus of a vector, so it has only magnitude. So if you cancel out magnitude, only direction survive. So unit vector basically define direction. Now in some book you will see that unit vector basically used in n cap. N cap is used as a symbol, and in some book you will see that if there is a vector with capital letter, then unit vector is specified with the small letter. So whatever be the notation, the definition remains same. We are trying to explain in a figure by using two different notation. So one vector, capital A vector, is the given vector with the larger magnitude and the arrowhead, but the above we have given small letter a with the cap. So a cap basically define the unit vector, so it directs from left to right. So whatever be the notation, so in some book you will get n cap, in some book you will get eta cap, in some book you will see that capital symbol is used to define unit vector, in some book you will get a small letter basically used to specify unit vector. So whatever be the symbol, the definition remains same. Unit vector basically whose magnitude is 1, and it specify only direction, and every vector has its unit vector. Now next one, we are trying to define addition of vectors. So addition of vectors basically the resultant of vector, or resultant of the given vectors, you can say. So let me read out. If a vector and b vector are the given two vectors, then addition of these vectors is basically r vector is used to define vector sum, because r symbolize resultant. That's why r is used to define the vector sum or addition of vectors. So r vector, where r vector equal to a vector plus b vector. Now you see, addition of vector is different compared to the algebraic addition, because in algebraic addition you will simply add the magnitude, but here you have to add the direction also with the magnitude. So that's why it is not same as that of the algebraic addition. You have to use some notation to define addition of vectors. Now you see, we have given here two vectors, a vector and b vector, in an arbitrary direction. Now if you have to define resultant of a vector and b vector, what you have to do, you have to use a rule, and that rule is your head of one vector should be with the tail of another vector. So what you have to do, you have to drag a vector parallelly so that the direction remains same. So I have dragged capital A vector parallelly so that the direction remains same, and also I have to drag b vector such that the head of a vector should be with the tail of b vector. So I have to drag b vector also, but what I have to do, I have to put that b vector at the head of a vector. So a vector I have dragged, making it parallel, and b vector also I have dragged, making it parallel. But as I have to define resultant of a vector and b vector, what you have to do, I have to put the tail of b vector with the head of a vector, because I have to find a vector plus b vector. So after dragging these two, I have to join another vector, or I have to join the tail of a vector with the head of b vector. So as it starts from a to b, that's why direction is upward, and that one gives the resultant vector of a vector and b vector. So you see, a vector and b vector are in continuous direction, but r vector is in opposite direction, you can say. So this can be verified by triangle law later on. So I have written here, head of one vector should be with the tail of another vector. Now similarly, if you have to subtract two vectors, what you have to do, a vector is already there, so b vector is already there, but what if I have to define negative of b vector, what I have to do, I have to put the arrow in opposite direction, making the length same. Now if I have to find out the resultant of a vector and minus b vector, what I have to do, keeping a vector same direction, I have to drag, and keeping minus b vector in the same direction, I have to drag, such that the head of a vector should be with the tail of minus b vector, and then I have to join the tail of a vector with the head of minus b vector. So you see, a vector and minus b vector are in same direction in the sense continuous direction, but r vector is in opposite direction. So here you are getting r vector equal to a vector plus of minus b vector. So ultimately you are getting r vector equal to a vector minus b vector, where r vector is the subtraction of a vector and b vector, you can say. So if you have to add two vectors, simply you have to use this rule, head of one vector should be with the tail of another vector. If you have to subtract two vectors, what you have to do, you have to take the negative vectors by putting the arrow in opposite direction, keeping the length same, and then you have to add that two vectors. Then you will get the subtraction of two vectors. I think you have understood what I am trying to say here. It's very simple. Now, as algebraic addition is different from the vector addition, that's why we have to use certain law. And here we are going to discuss parallelogram law and triangle law. Parallelogram law in details and triangle law only the statement, because it is almost same. So what is parallelogram law? It says that if two vectors are represented by the two adjacent sides of a parallelogram, then the diagonal that passes through the intersecting point of the two adjacent sides gives the vector sum. So let me read out. If two vectors are represented by the two adjacent sides of a parallelogram, then their vector sum is represented by the diagonal that passes through the intersecting point of the two adjacent sides. So in this figure, a vector and b vector are the given vector. So intersecting point is at a, small a. So r vector is the diagonal that passes through the intersecting point of the two adjacent sides. So r vector is nothing but the vector sum of a vector and b vector. Now this figure we have explained it in details. So that is your angle between a vector and b vector is your alpha, and diagonal makes an angle beta with b vector. So you see some construction we have done. In parallelogram, opposite sides have the same magnitudes. So AD is your a vector, so BC is also a vector. It's a parallel and magnitude is same, and AB is your b vector, so you can say DC is also b vector. Now the construction part, what we have done, we have extended b vector, or we have extended AB to till E, and we have dropped a perpendicular from C to BE or AE, you can say. Now the length define the magnitude, and if you take the component cos alpha, B is nothing but is your a cos alpha, and C is nothing but is your a sin alpha. If you take sin alpha and cos alpha, the trigonometric value you will get. Now if we consider the triangle, right angle triangle AEC, because we have drawn perpendicular CE over extended AB. So AEC is your right angle triangle. So you have to use the Pythagoras theorem. So hypotenuse square equal to sum of the two sides square. So AC square equal to AE square plus CE square or EC square. Now AC is your length, so R is your magnitude without any vectors notation at the head or at the top. So R square equal to AE is your what? AB plus BE. So AB is your B and BE is your A cos alpha. So B plus A cos alpha whole square, and EC is your A square sin square alpha. So if you have to expand, B square plus A square cos square alpha plus 2AB cos alpha plus A square sin square alpha. So B square plus A square cos square alpha plus sin square alpha plus 2AB cos alpha. So B square plus A square plus 2AB cos alpha. So R you will get root over B square plus A square plus 2AB cos alpha. So if you find tan beta in the right angle triangle, so you will get perpendicular by base, that is your CE by AE. So CE is your A sin alpha and AE is your B plus A cos alpha. So beta equal to tan inverse of A sin alpha by B plus A cos alpha. So you see beta is nothing but the direction specified with respect to the B vector by the with respect to the B vector and the direction of what? Direction of the diagonal, and diagonal is nothing but the vector sum. So R is your magnitude and beta is your direction. That can be defined using parallelogram law of vector addition. I think you have understood. It's a very simple geometry. Now next one, we are trying to define triangle law. So what is this one? If three vectors are represented by the sides of a triangle, then the sum of two vectors which are in same direction is equal to the third vector which is in opposite direction. So you see A vector and B vector are in same direction in the sense they are in continuous, and R vector is your vector sum, you can say it is in opposite direction. So if you are applying triangle law, then you have to you can write basically R vector equal to A vector plus B vector. And if you check out this part, it becomes clear for you. We have used that law, triangle law basically. Now you can substitute alpha, and you can define R and beta in different cases of alpha. So if alpha equal to 0 degree, then R equal to B square plus A square plus 2AB root over. So you can say A plus B whole square. So A plus B whole square means A plus B. And beta equal to goes to 0. It means if two vectors are in same direction, then the resultant is also in the same direction. And resultant is nothing but the sum of the magnitude of the two vectors in the magnitude resultant. If you substitute alpha equal to pi by 2, then you will get R square equal to A square plus B square, because cos pi by 2 is 0. And parallelly you can define beta tan inverse of A by B. So in this way you can substitute any value for alpha, and correspondingly you can define magnitude and direction. So this is very important because numericals may be there. So please go through and find out your doubt and try to put your doubt. Thank you.